First, we're going to weigh the raw material, and then we're going to measure the CO2 gas. What we're doing now is making sure that there's no more magnesium carbonate to react, so that we can measure all of the CO2 that we had locked, all the carbon dioxide that we had locked into that raw material. This is going to be where we capture the CO2, and this is where we'll react. Let's pull it to about 40. We can just slowly start opening this up and see what happens and measure the volume of gas. Oof. That's a lot. We barely. That's 20 cc's of gas in just a second. CO2 emissions is the cause of all the effects, the negative effects of global climate change, global warming. It's a result of primarily CO2, by far CO2. This was an effortless and unintentional way of capturing carbon. This wasn't known. We weren't. In fact, all the papers that we read on accretion never once mentioned the side reaction that's taking place of capturing carbon. We're using solar power to remove some of the CO2 that we also are putting in the air through other means like transportation, manufacture, whatever. CO2 is the problem here.
So this would just need to be stored?
Stored, like anything else, as long as you don't re-release it by adding a strong acid to it. This would stay for thousands and thousands and thousands and thousands of years. This can like buy humanity time. If solar panels were spread out with some anodes and cathodes and the material that's collected in these bodies of water, I mean, you don't have to collect them and store them like nuclear waste or something. As long as you don't acidify the water aggressively to re-release it, you're kind of giving yourself like a little, you're undoing what we do. The results were much better than I thought it would be. Just under half a liter of CO2 was captured in 5 grams. There's half a liter of carbon dioxide trapped in here that the accretion did. I'm trying not to use expletives, but pretty cool.